Hey, I guess you knew this was coming. Volumes of cylinders and prisms. Volumes would come after areas, wouldn't it? And we've done that pretty well. What's a cylinder and a prism? Well, we've got a cylinder over here, and there's some prisms here. These two. A prism is what? What is a prism? A prism is a body, a three-dimensional shape, which has uniform cross-section right along its length. It's the same shape, if you like. We're going to do a little bit of that now in a minute. Here's an interesting one here. That's a prism in a sense. It's got a hole in it. Hey, like a tunnel there. Don't crawl in there, mate. And then over here, well, you know what I've got that for. This is very thirsty work. We're going to have to have a drink from time to time. Oh, well, sort of. It is a cylinder, isn't it, with a little bit missing up here. So that's an interesting problem there. So what we're going to do is have a look at how do you work out volumes. And what I'd like you to do in this unit, like the last one, is could you take it to the next level? Just don't write down a formula. Say, hey, where'd that come from? Do I really see that? So come on down and let's have a look at, see if we can work out some volumes here. Well, hang on, what's a volume? Well, do you mind if I use the same definition as before? The volume equals the amount of space. Hey, this was the area definition. Can you do that? The amount of space inside the figure. Except here, what makes it a volume and not an area if we use this same word? It's how you would measure the space. This is a three-dimensional figure now. So flat squares, centimetre by centimetre, metre by metre, kilometre by kilometre, won't do. So what do you think we would do? Well, because it's got three-dimensional shape, let's make our little squares into cubes now. That isn't very good. Let's have a look. Make them into cubes. So length and breadth and depth are all the same. 1 centimetre, 1 centimetre by 1 centimetre. Our little cubes there, or 1 centimetre cube, we call that. Let's see how many of those fit inside here. Let's start building here. Oh, there's going to be a lot of work to do that. Is there a formula way of doing that? Well, let's have a look at looking at how many squares there are across an end. So let's put in our squares there across the end. Okay, and this way as well. Along here, we could do that. We'll have lots of squares there as before, working out the area. How many have we got? Well, if this was the length and this was the breadth, we've got number of squares. Let's look at it. Number of squares equals L lots of B, same as before. So it's length times breadth. Do you remember that from the last unit? That was what we found there. Quite understandable, that one. So now what are we going to do with these squares? We're going to make cubes. How are you going to make cubes? Let's keep going here. Squares across the end. To make cubes, well, let's slice it this way. Go 1 centimetre down there. 1 centimetre. What's going to happen if we slice it through there? Going to produce little cubes are going to come out. Cubes are going to drop out. The squares are now going to have depth. They're going to become cubes. How many times can you do that? Well, let's say it's d centimetres high here. So the number of cubes will be d slices, d lots of L times B. Every one of those squares will give a cube. So how many cubes will we have? It'll be D times L times B. And you know we usually write that the other way around. Volume is length by breadth by depth of a figure like this. But I really don't want you just to memorize off the formula. rather to say, well, I can see it. I can see what's happening here. We're slicing this cube, this rectangular prism, into cubes. Squares become cubes. Let's have a look. 2D, a square is now becoming a cube, and that can be used in 3D to measure the amount of space contained within a 3D solid. Do you get it? Let's do some more. Come on down here and let's have a cylinder. Alright, now let's follow the same idea. The area of the end, let's slice it up and find how many square centimetres there are. Of course, there's little halves and things in here, and when you add them all up, when you finish going across the whole end and making squares everywhere, then how many have you got? Do you remember? The area of that circular end is pi r squared. So you've got pi r squared, squares across there, where r is, what is it? The radius out of there somewhere. Okay, can we do it again? Can we make our cubes? Let's slice it along here. What is this anyway? I'm getting hungry. It looks like Metwurst or a roll of Fritz or something like that. Are you hungry at this stage? I tell you what, I'm getting thirsty as well. I think we'll go back and have a drink up here. Oh, yep. Come back down. And let's keep going with this cutting. Thirsty work, this. Okay, we're cutting, and every time we cut, the squares on the end become a cube because it's a centimetre deep. We're going to make a layer of cubes here every time we slice across that section there. So, what's the number of cubes? The number of cubes is going to be pi r squared, the number of squares on the end, times the number of slices, isn't it? The number of times we make those squares into cubes. And if the depth of this cylinder is d, it's going to be pi r squared times d, or h if you want. And so the volume of a cylinder is the area of the end times the depth, or you might call that the height, the way it's standing up there. Please yourself. Do you get it? Squares are becoming cubes. We now have a volume measurement. Let's do some more and come down here. Here's two more shapes. Do you think we can do the same thing? Let's check it out. What do you think we need to make sure of when we're doing this, when we're slicing through here? What do you think we have to make sure of if it's going to work, it's going to be consistent every time? The answer is the area of the end has to remain the same as you go along the body. It's said to be a cross-section. When you cut across a body's end like that, you're sectioning or cutting across it, it must be uniform, must be the same shape every time you take a slice. Because what we're going to say here, again, if this is the depth of the body, the volume, the number of cubes, is the area of the cross-section, what's down the end, how many squares we've got there, and every time we slice it, we're going to make a cube, so it's d slices, area of cross-section times d. In this one, what would the area of the cross-section be? Let's divide it up, because we've learned this already. We've got those skills now. So we will come across here and make a rectangle, and then we'd need the height down here for the triangle. And we could work that out, the number of squares on the end, and then away we go, slice it up. Okay, what about this one over here? This is called a triangular prism, because the shape on the end is a triangle. Okay, so can we do the same here? We could find the number of squares in here. Yep. What would that be? The area of the end. The number of squares is a half base times height. Then let's make them into cubes. Let's slice down here. Keep slicing. Every time we slice, out come cubes instead of squares. Lots of little cubes falling off here. And so how many slices? We've got a depth to this body. So here it's going to be the volume is the area of the cross-section. Let's abbreviate it to that. Times the depth, which would be a half base times height times the depth there. and this would be in cubic centimetres or cubic metres, depends on how big the body is. Okay, have a think about that. I really want to take it to the next level. Don't just grab a formula. Say, hey, where did this come from? Do I really see it? See what's going on here? Let's go down and summarise some of this, and taken some screen clippings from Pearson's here, textbook for the new national curriculum. And we've got some definitions up here we've already covered. We'll read it out now. Prisms and cylinders have a uniform cross-section. Because of this, the volume of these solids is found by multiplying the area of the cross-sectional shape on the end, they call it the base, by the height of the solid. Okay, because what do you want? You want the area squares to turn into three-dimensional shape, or three-dimensional measures within that shape of how much is there. So three-dimensional. So here squares become cubes if we're going to find the amount within the body. All right, so just note here, you don't really need to say base and height and so on. It depends on which way the body's lying here. This might better be said, look at these down here. It's not really height, it's the depth of the body, isn't it? So you could use depth instead of height. You know, I suppose if it was up like this, standing on its base like that, you could call it height. And that's what they're saying here. It doesn't necessarily have to stand on that section which is uniform. But generally we would use height if it's like this, and probably D for depth if it was like this. Okay, so here's the summary, and they're using the idea that A is the area of the cross-section, and then times the height or the depth of the body. So here we go over here, rectangular prism, the area of the end is A, which is length times width, and then the depth of it. It's triangular prism here, area of the end, which is a half base times height, times the height or depth of it. Cylinder, we've just done, area of the end, pi r squared, times the height or depth of it. Okay, so you can put down your formula in a couple of different ways there, but the general formula, of course, is the volume is the area of the cross-section times the length or depth of the body, and this area must be the same every time you slice, so it's got to have a uniform cross-section. Okay, and that shape is called a prism. Alright, come on down, let's look at an example, and here's one here, and if you try to find the area of this end now, because you can see as we slice back, that's going to be constant the way they've drawn this diagram. It's a triangular prism, so you know there that that's going to be constant. A prism has a uniform cross-section. So the volume is the area of the cross-section times the depth, which is a half base times height, because it's a triangle, times the length of it. So it's a half by 10 by 12 by 4, and of course there are 3 centimetre measurements there. It's in centimetre cubes. Just remember, to make something to measure the space within this object, we have a square, which is a centimetre by a centimetre, becoming a cube with that slicing, and therefore the unit now is a centimetre by a centimetre by a centimetre, or 1 centimetre cubed. Okay, centimetre squared to centimetre cubes, a three-dimensional shape now. Okay, come down and let's have a look at the final bit in this little presentation now, and we're going to talk about the capacity. So a little bit different. We've been talking about measuring the space inside a three-dimensional shape, and that's centimetres cubed, and now we're going to say how much volume or amount of liquid or gas can the container hold. And you know that we usually use litres. So 1 litre is 1,000 millilitres, and 1,000 litres is 1 kilolitre. These are commonplace units, and 1 millilitre is a centimetre cube. The centimetre cubed is a space measurer here in 3D space, and this is a volume measure, 1 millilitre, and therefore 1 centimetre cubed is equal to 1 millilitre, 1,000 centimetre cubes is 1 litre, and 1 metre cubed is 1,000 litres or kilolitre. Alright, so you would have seen some of these before. Need to remember the prefixes. Milli means 1,000th. Alright, 1,000 is equivalent to 1,000th of the unit, so a millilitre is 1,000th of a litre. And kilo is the other one here, which is equivalent to 1,000 of the litres. 1,000 of the units. So kilolitre is 1,000 litres. So I have to keep practicing with that as we go down and do some problems. Now let's have a look at an example of that one then. So if you're finding the capacity, it says answer in litres, and so the first thing to do, of course, is to find the volume in centimetre cubes and then to convert it. So we have a cylinder, so you can see here they've shaded. A cylinder has a uniform cross-section with pi r squared times the height of the cylinder. So the radius here, watch this, the diameter is 30, so the radius is 15. Don't forget to halve that. So the radius is 15, so it's pi r squared by 50, and then this is approximately 2 decimal places because pi has an infinite number of decimal places, so we're going to round it off. This is how many centimetre cubes we've got, and to 2 decimal places, and then dividing by 1,000 to change to litres, because there's 1,000 centimetre cubes produce a litre, or 1,000 centimetre cubes rather, is the space occupied by 1 litre of volume or capacity. So it is actually moving the decimal place back 35.34 litres. Do you get it? Not too bad now. Let's go and practice some problems and see what you think. So here's your basic ones, the fluency ones. So just make sure as you're dealing with these solids here that they have uniform cross-section. Our method only works where the cross-section is uniform. We're going to have some interesting ones coming down, so you can pause the presentation now and have a go at question 1. We've got the set of answers over on the right and see what you think. Make sure you watch the units. Some of these are measured in millimetres, some are in centimetres, okay, some are in metres there. So watch the units. Oh, well, here we are. The can of Coke's empty now, mate. I've been drinking pretty regularly through this presentation. Very thirsty work. But here's the can. I want you to find the capacity of this, and we are not going to try to estimate this. Okay? You're not going to try and estimate that bit here. Assume that the can is a regular cylinder. You might give some thought to how would you estimate the amount of volume lost by that? There's sort of almost a little triangle missing there, isn't it? And if you turn that around, what would you have? What sort of volume would you have if you took out that little bit around the top? Would you like to estimate that? That's a good chance for discussion within the class there. Okay, so pause it, have a go. Number 9 here. Some interesting ones. Some really interesting shapes on the end. Oh, the tunnel's back again. And that was at the beginning of the presentation, if you remember. So pause that now and have a go. Let's move on to the next level, understanding. So these are a bit harder, an interesting shape down here, and these two here as well. Think about this, because they're a little bit more difficult, and there are the answers for you. Let's finish off now with a couple of other harder problems, reasoning problems. Okay, you see these are trenches. Okay, so they have a depth here, 85 centimetres, so this is the end section, so these are all being dug down. Think about that. Here you are, above ground pool we've got here. These are interesting problems, and say, hey, I can actually work out some useful stuff now. Anyway, the answers are there. Pause it and have a go. Come down now to the last level here, the open-ended questions. We've got to sort of devise your own diagram and think about possible answers. So again, there's just sample answers here. But if you can get to that level, you've done really well. All right. I hope you enjoyed that. You can see we might have to still do some more volumes, because what do you do if the body hasn't got a uniform cross-section? That's an interesting question. Anyway, catch you later. For now, it's cheers from me.